Let's now see a different version of collaborative filtering called item-item. The user-user collaborative filtering algorithm we saw recommended items that other users who are like you also liked. An alternative view that often works better is called item-item collaborative filtering. Here, we recommend items that are like items that you like. For a given item I, we find items that are similar, and we estimate your rating for I based on ratings for those similar items. All of the similarity metrics and prediction functions can just be as they were in the user-user model. So the algorithm is rate an unseen item I as the mean of my ratings for other items weighted by their similarity to I. So more formally, let's suppose we have a set N of items rated by me and similar to this unseen unit I. Let's call it 2. Let's say we have 2 similar items. For each of those similar items, we have my rating, I'm X, my rating on that item, that should be a J. We have the similarity of that rated item to my unrated item I. So my rating, I'm X again, my rating on I is the sum over all the items that are like I of my rating weighted by their similarity to I. The weighted mean of my ratings for other items that are similar to I weighted by their similarity to I. Let's walk through an example again. Here's a utility matrix for users rating movies, and we'll set n equals 2, meaning we'll be rating an unknown movie by averaging the 2 most similar movies that are rated by that user. Let's say we want to know what would user 5 think about movie 1. So we're going to try to fill in that cell. First, we have to do neighbor selection. We want to find the 2 movies, we picked n equals 2, that are most similar to movie 1 and are rated by user 5. And we're going to use mean-centered item overlap cosine as similarity. So we're going to compute the mean rating for each movie, so for each row, and subtract it from the whole row. And then we'll compute item overlap cosine similarities between rows to find which movies are most like movie 1. I'm going to give you a hint. It's going to be movies 3 and movie 6. So I'll just show the computation for those 2. First, we need to do mean centering for each movie. So we're going to take the mean of row 1. What's the mean of row 1? It's 1 plus 3 plus 5 plus 5 plus 4 over 5. That's going to be 18/5. There it is, written out neatly. And if we do that for the 3 movies we're talking about, the unseen, unrated movie 1, and the 2 that are going to be the nearest neighbors, movie 3 and movie 6, we computed separate means for movie 3 and a separate mean for movie 6 and subtracted out those means. So now the low ratings, like 1, have become negative. Now we just need to compute that cosine to see how similar these movies are to movie 1. Again, I'm just computing it for movie 3 and movie 6, so this video doesn't become endless. So for movie 1 and movie 3, we do the item overlap cosine. So we're going to be computing the dot product, and that means we're going to be multiplying elements for user 1, user 9, and user 11. None of the rest have elements in both vectors. So we'll be treating these as if they're vectors with 3 elements. So here are the cosines. For rows 1 and 3, they both have values for those 3 users, 1, 9, and 11. And here's our cosine with our 3 values and our 3 values. And for rows 1 and 6, they have values for users 1, 3, and 11. So we get our 2 cosines. So our similarities of movie 3 to movie 1 and movie 6 to movie 1, 0.658, 0.786. We can put that 658 and that 768, in this column. In real life, of course, we'd have to compute the similarity of all the movies to movie 1 in order to find the 2 most similar, but I'm cheating by telling you that all the other estimates are smaller. So we just need the 2 most similar movies because we're doing n equals 2. So now we just take the weighted average of this 2 and this 3 to fill in the blank for movie 1. If we took the non-weighted average of 2 and 3 is 2.5. it turns out the weighted average, here's my computation down here, is slightly different, and it turns out weighted averages work slightly better. Basically, it's saying movie 6 is slightly more similar to movie 1 than movie 3 is to movie 1, so we're going to weight movie 6 a little more. In practice, item works better than user. Why is that? Items tend to be classifiable in simple terms. For example, music tends to belong to a single genre. It's hard to imagine how a single piece of music could be both a Beyoncé song and Bach Baroque. On the other hand, there are individuals who like both Beyoncé and Bach and who listen to both. Furthermore, items are relatively constant. A Bach fugue is always a Bach fugue, but people are dynamic. Their tastes change. The consequence is that it's easier to discover items that are similar than users that are similar. In summary, collaborative filtering works for any kind of item. We don't need to define a set of features that define the item. On the other hand, collaborative filtering has some minuses. It has a cold start problem. Whether we do item or user similarity, we need enough users in the system to find matches. We have a sparsity problem. The user ratings matrix is sparse. It can be hard to find users that have rated the same items. It's hard to recommend an item that hasn't already been rated. That's called the first rater problem. There's a popularity bias. We can't recommend items to someone with unique taste. We tend to recommend popular items, and it can lead to all sorts of problems we'll have to deal with, like filter bubbles and radicalization. We've now seen both the user and item versions of collaborative filtering.